A plant dismissed as roadside trash holds the molecular key to one of humanity's deadliest diseases. In 2015, Chinese scientist Tu Youyou stood before the Nobel Committee to accept the prize in physiology or medicine for discovering Artemisinin, a compound that has saved millions of lives from malaria. Her research revealed what traditional Chinese healers knew for 17 centuries. The compound extracted from this plant kills malaria parasites faster than any synthetic drug ever created. Clinical trials demonstrated artemisinin-based treatments cure malaria in 3 days, while older drugs required weeks and often failed against resistant strains. Yet the plant itself grows wild along highways, in vacant lots between sidewalk cracks. Modern pharmaceutical companies have spent billions trying to synthesize the compound in laboratories. They failed. Nature produces artemisinin through a biochemical pathway so complex that industrial replication remains economically impossible. The irony is profound. The cure for a disease killing 600,000 people annually grows free, ignored, treated as invasive vegetation. Municipalities spray herbicides to eliminate it from public spaces. We walk past salvation on our way to Chinese medical texts from 340 CE document sweet wormwood as treatment for intermittent fevers, the hallmark symptom of malaria. J. Hong's Emergency Prescriptions Kept Up One Sleeve described steeping fresh plant material in cold water, not hot tea. This detail proved critical 17 centuries later. Tu Youyou spent years trying to extract the active compound using traditional hot water methods. The extracts showed inconsistent anti-malarial activity in laboratory tests. Then she returned to the ancient texts. Ge Hong's instruction to use cold water revealed the problem. Heat destroys artemisinin. The molecule's 3-oxygen peroxide bridge, responsible for killing malaria parasites, breaks down above 60 degrees. Ancient healers understood empirically what modern chemistry explains molecularly. They preserved the medicine through temperature control without understanding thermodynamics. When Tu Youyou switched to ether extraction at low temperatures, the anti-malarial activity increased 30-fold. The breakthrough came from respect. Artemisinin operates through a mechanism synthetic antimalarials cannot replicate. When the compound encounters iron-rich malaria parasites inside red blood cells, its peroxide bridge destabilizes. The reaction generates free radicals that shred parasite proteins and cellular membranes within hours. Conventional drugs like chloroquine block specific metabolic pathways, allowing parasites to develop resistance through genetic mutation. Artemisinin attacks multiple cellular targets simultaneously. Evolution cannot adapt quickly enough. Malaria strains resistant to every synthetic drug remain vulnerable to artemisinin. The World Health Organization now requires artemisinin-based combination therapies as first-line treatment for malaria globally. Over 2 billion doses have been administered since 2000. Mortality rates in sub-Saharan Africa decreased 60% following widespread artemisinin adoption. A roadside weed, Artemisia annua, refuses to cooperate with industrial agriculture. The plant is an annual that thrives in disturbed soil, poor drainage, and neglect. Commercial cultivation attempts revealed frustrating inconsistency. Artemisinin content varies wildly between plants, from 0.01% to 1.4% dry weight depending on genetics, soil, harvest timing, and environmental stress. Farmers cannot standardize production. Pharmaceutical companies demand predictable yields. The plant demands freedom. Genetic modification efforts to increase artemisinin content in laboratory strains created plants that grow poorly in field conditions. High artemisinin varieties produce fewer seeds, shorter stems, reduced biomass. Yield improvements in the laboratory vanish in actual soil. Meanwhile, wild populations along roadsides maintain moderate artemisinin levels without fertilizer, irrigation, or human intervention. The system wanted a crop. Nature provided a survivor. We reject. Scientists have mapped the complete artemisinin biosynthesis pathway, 14 enzymatic steps from a simple sugar to the final antimalarial compound. Synthetic biology projects at Amiris and Sanofi engineered yeast cells to produce artemisinic acid, a precursor requiring only chemical oxidation to artemisinin. The fermentation approach promised cheap, consistent production independent of agricultural variables. After spending $55 million on development, semi-synthetic artemisinin reached market in 2013. It cost more than plant-derived artemisinin. Yeast fermentation required expensive sterile facilities, precise temperature control, specialized equipment. Farmers in East Africa can grow Artemisia annua in open fields using rainwater. The industrial solution was technologically impressive and economically absurd. By 2016, semi-synthetic production had failed to displace plant cultivation. Nature performs complex chemistry for free. We cannot compete with photosynthesis. The lesson extends beyond artemisinin. Industrial food systems dismiss plants they cannot control. Artemisia annua contains over 600 identified compounds beyond artemisinin. Historical texts document the plant's use for digestive complaints, fever reduction, and parasitic infections beyond malaria. Modern research has identified artemisinin's effectiveness against schistosomiasis, a parasitic disease affecting 200 million people in tropical regions. Laboratory studies demonstrate artemisinin induces apoptosis in certain cancer cell lines, particularly breast cancer and leukemia cells that accumulate iron. The mechanism mirrors its anti-malarial action, iron-catalyzed free radical generation. However, artemisinin and its derivatives are pharmaceutical compounds requiring medical supervision. Self-treatment is dangerous due to narrow therapeutic windows and potential toxicity. The plant's value lies in scientific research and controlled medical application, not home remedy preparation. What matters is recognizing that roadside vegetation contains molecules pharmaceutical companies spend billions attempting to synthesize. We spray it with Roundup. The absurdity speaks to our fundamental disconnection from botanical wealth. We cannot see value in what we have not commodified. Artemisia annua grows spontaneously across every continent except Antarctica. It requires no cultivation skill, tolerates poor soil, resists most pests, self-seeds aggressively. A single plant produces 100,000 seeds. In regions where malaria kills children daily, the cure grows wild in ditches. Yet artemisinin-based treatments remain unaffordable for many who need them. The pills cost $1 to $2 per dose, a fortune in economies where people survive on less than $2 daily. Pharmaceutical supply chains, distribution networks, and profit margins separate the plant from the patient. Some African communities have returned to cultivating Artemisia annua locally, drying leaves for tea. The World Health Organization discourages this practice, citing inconsistent dosing and incomplete parasite clearance that could promote resistance. The debate reveals the tension between pharmaceutical control and botanical access. Science discovered what traditional medicine preserved. Industry commodified what nature provided freely. We transformed a common plant into an expensive intervention. The Nobel Prize recognized brilliance in rediscovery.